Hello everyone, I am intern at Emergent Technology and I am doing internship of a embedded system and do this internship we build a project of microwave oven simulation. Myself Swati Malina Chingonde. Table of content. What is a microcontroller? What is an embedded system? In an embedded system, embedded C, programming of an embedded system, component of an embedded system, project overview and conclusion. Coming to the next slide, what is the difference between microcontroller and a microprocessor? First, here is a microprocessor. All separate component of in component chip. Microcontroller all component in a single chip. Second, more flexible, and microcontroller is a less flexible. Microprocessor is a more design complexity. In a microcontroller, less design complexity. Here, we assume we consider the microprocessor is a heart of computer and microcontroller is a heart of embedded system. We coming to the next slide. What is a microcontroller? We know the in a microcontroller, we studied 8051 and peak microcontroller. In this our project, we uh, do the project on peak microcontroller. A microcontroller is an integrated circuit which is capable to perform specific tasks in operation of a embedded system. Operation of an embedded system. A typically microcontroller include a processor, memory, and input-output peripheral on a single chip. Coming to the next slide, application of a microcontroller. First is a GPS system, medical device. Second, third is a automotive system. Fourth, ATMs. Fifth, defense and aerospace. Six, home appliances, and seven is a banking sector. Coming to the next slide, categories of a embedded system. There is a category of embedded system which is real-time system, standalone system, networked, mobile. Here, benefit of a embedded system. Reliability. It can provide reliable performance over an extended period with a few failures. Cost effectiveness. Cost effectiveness, lower cost compared to the general purpose costs. In the power consumption, there is a help to reduce energy cost for a overall system. Fast performance, there is a no humans interference to complete the task and specific works. Easy to manage, which is manage the system in a efficient way. Coming to the trends in the embedded system. First is a low power consumption, more security second. Third is a connectivity. Fourth is a robustness and fifth is a computer power and architecture. Coming to the design matrix. Design matrix. We know the which parts are included in design matrix. First is a unit cost. Unit cost. In the unit cost, the monitoring cost of the manufacturing each copy of the system excluding NRI cost. Uh, which NRI cost we see in a next NRI cost. NRIE cost is non-recurring engineering cost. It is the one-time cost of designing the system. Once the system is designed, any of the any number of the units can be manufactured without in recovering any additional designing cost. Hence, the term non-recurring is happen. Coming to the size. In a size, the physical space required by the system often measured in a byte for a software and a gate or a transistor for a hardware components. Power. In the power, it is the amount of power consumed by the system, which the way determine the lifetime battery or the cooling requirement of the ICs. Since more power means more heat in this power consumption. Uh, Performance, the performance of the system, the execution of a time of system. Flexibility, the ability to change the functionality of the system without in recovering heavy NRE cost. The software is typically considered very flexible. Now we go to the embedded C. What is mean by embedded C? Embedded C is one of the most popular and commonly used programming language. The development of an embedded system. Embedded C programming plays a key role in a performing specific function by the processor. We know all things about embedded C. Now coming to the project overview. In this project, we develop a microphone using PIC 16F877A microcontroller in a PIC sim lab. Micro oven offers a precise temperature control, adjustable cooling time, and a user-friendly interface. Next, introduction to the microwave oven. A microwave is a kitchen appliance which helps to heat the cook and food which available in day-to-day life. Microwave converts electrical energy into a electromagnetic radiation which is called as microwave. This is a short explanation of a microwave. Coming to the software tools required for this project, MPLAB X IDE, MPLAB XC8 and Peak Slim Lab Simulator. That's first MPLAB X IDE. The IDE which we will be using for an embedded system developed with a PIC MCUS is called as MPLAB X IDE. It is a product of a micro chip which is so powerful and versatile, and it is used to create a new project and helps to write the assembly language program for an interface, and it is a widely used software tool in embedded system. Next, MPLAB XC8 compiler. In the MPLAB IDE by default it does not include any compiler. We can use to write assembly language program without any need for any compiler. But if we want to write a code in embedded C language, we need to install a separate compiler. Now we know what is including to install a compiler. Hashtag include XCH header file contain the definition of all register of PIC microcontroller. After we finish the writing the program, we need to compile the code and to generate the hex file and to see if there is any error in the code. To compile code, click the build option. If there is no error, the code in the code it will be display message of build and generate a hex file. So we know we know to run the program. Next, Peak Slim Lab Simulator. The Peak Slim Lab Simulator is a real-time emulator of a development board with the MPLAB X DGB debugger integration. In the Peak Sim Lab supports several device spare parts that can connect to the board for a simulation. We know the Peak Sim Lab works which is used in our projects. Now next, Peak Slim Lab peripherals, LEDs, digital keypad, interrupts, timers, clock input output, SSD, CLCD, matrix keypad and analog input, which is the peripheral of this software tool, Peak Slim Lab. Now next coming to this is our Peak Slim Lab structure. This is the work of the Peak Slim Lab in project. Now type of cooking mode. Micro mode for heating the food item. This mode is used. Grill mode for frying the food item. Convection mode for a deep frying of a food item. This convection mode is used. This is the three type of the mode which is used in microwave oven simulation. Now next conclusion of the project. Overall, we observe working of a difference mode in a microwave oven using PIC microcontroller in a PICSIM lab, which is very useful to daily day-to-day basis of human beings. Now last, thank you so much.